Welcome, everybody. Good morning. Many-to-many in DAX. Who has already used DAX? Some. Okay. So you will be the target of my question next. Who was not at in my session yesterday? Some. So you need to get again the explanation of who I am. I'm Alberto Ferrari, coming from Italy. I work with Marco Russo at SQLDay.com. SQLDay is our company. And we do data warehouse courses, workshops, we write books. We do a lot of stuff about business intelligence. In the last few years, I specialize just on analysis services, tabular, and the DAX language. Then we are SAS Maestra, MVP, MCP, and blah, blah, blah. I'm not here to sell myself. The topic of today is many-to-many relationships. I guess you know what many-to-many relationships are. And the classical example of many-to-many relationship is, this is coming from a banking data model. We have transactions, banking transactions, so you deposit or you draw money. Transactions are linked to accounts, and an account can be owned by many customers. You might have an account with your wife, an account with your friend, an account with your company or whatever. So there are many customers for a single account, and there are many accounts for a single customer, and of course there are many customers for a single account, because I can have an account with other people. The typical way of modeling it is to put a bridge table in the middle, so you can repeat ID account and ID customer on this bridge table, and this states that a single account is owned by many different customers. That's a classical way of modeling many-to-many relationships. The problem of many-to-many relationship is that in multidimensional you have many-to-many relationship in the data model. So if you want to use many-to-many relationship, you simply create a relationship of type many-to-many between two dimensions, and then you are done. You don't need to do anything else. Performance are not exciting, or performance really suck, but at least it's easy to model them. In tabular, this does not work. Anybody has an idea why it doesn't work? Come on, don't be shy.
The flow of filtering.
The flow of filtering. In tabular, when you put a filter on the customer table, the filter on the customer is automatically propagated to the bridge table, because there is a one-to-many relationship between the bridge table and the customer table. So, for example, when you filter products, the sales of products are filtered. When you put a filter on the dimension, that filter is automatically propagated to the fact table. And this is the standard behavior of tabular. But the problem is that the filter propagates from the one side to the many side, but does not propagate from the many side to the one side. In fact, if you filter the sales, you are not really filtering the products. You are only restricting the number of sales you see, but you see all the products in the dimension. And that's the standard behavior of tabular. So with many-to-many, what happens is that you put the filter on the customer table, that filter is propagated to the bridge, but then it stops there. It does not propagate to the dim account. And because dim account is not filtered, the fact table is not filtered either. And so by default, out of the box, many-to-many relationships do not work in tabular. And I heard so many times people complaining about the fact that tabular does not support many-to-many relationship. It's not that it does not support them. You need to write some complex DAX. I would not say complex, some advanced DAX in order to make the flow work. So multidimensional handles many-to-many, and it's there and it works, while tabular does not have many-to-many. The only kind of relationship which is present in tabular is one-to-many relationship between two tables based on a single column. But we have DAX. There is the DAX language, and by writing some DAX code, we will be able to support many-to-many. Before looking at the formula and understanding how to make many-to-many work, it is useful to look at the final result we want to achieve. So, I will use Power Pivot for all these demos because it's easier to use. Now the next session, but in this one, I created a simple data model that is very similar to the one you have seen before on the screen. Just a few seconds that it loads. Okay. You can see here we have, what's that? You can see here we have the wrong workbook, but if we open the correct one, then okay. Do a rewind, and let's start from, you can see here. You can see here that we have customers, the bridge between accounts and customers, and the account table. Then we have the fact table, the fact transactions, the type, and the data. This data model is very small. It contains just a few rows. I guess 4 customers, something like 6 or 8 different accounts. And I put names in the model so to make it easier to understand what happens. Customers are just 4, Mark, Paul, Robert, and Luke. And in the account name contains the name of the owner of the account. So the account Mark Robert is owned by Mark and Robert together, and the account Mark Paul is owned by Mark and Paul together. So when we look at the pivot table, it will be easier to understand what's happening. Now, if you create a pivot table over this model, and you can put, for example, the account on the rows. If you put the account on the rows and from the fact table you take the sum of amount, you get correct results. Because we are slicing by account, and account is immediately linked to the fact table, so filtering works fine. The problem arises as soon as you take the dim customer and put the customer name on the table. You see that the result is wrong. It is as if the account Mark is owned by everybody. The account Mark Paul is owned by everybody. And this is just because many-to-many are not working. You can see the problem both in this way, or even if you switch the 2 columns, you put the customer name before the account, and it is like each customer owns all the accounts. Our goal will be to use not sum of amount, but a different measure, which I call amount many-to-many. If you put amount many-to-many in the pivot table, you see the correct result. The account Mark owns the account Mark, Mark Paul, and Mark Robert. Paul owns Mark Paul and Paul. So our goal is only that of writing this formula. And please note, you probably already know that many-to-many are non-additive. This is absolutely normal. It is like Mark has $2,800 and Paul has $1,700. This is not true. If you sum all these values, you will not get this number. You will get a lower number because the same account is shown for all the customers. This is normal. That's standard behavior of many-to-many, but normally drives customers crazy. So they look at formulas and they complain with you because the formula is not working. It always takes some time to explain them that the formula is working. It's that they are not understanding numbers. So our goal is only of writing this formula. As you will see, it's just a 3-line formula. It's very, very compact, but it's not easy to understand. If you look at the formula amount many-to-many, do we have a better amount many-to-many? No, I don't have the best amount many-to-many. Anyway, the formula is this one. Calculate sum of fact transactions amount where we filter dim account where name of customer greater than 0. It's a very simple formula, but we need to understand. And to understand, we will take some time. So, now we have the problem. We know we need to write some DAX code to traverse the many-to-many relationship in the correct way. Next formula, this is what I said. The formula looks like this. Before I had a measure here, now I expanded it to the complete pattern. Calculate sum of transactions amount, where I filter the accounts using a specific formula. Do not even try to understand or to get a feeling of the formula right now. There are slides that will help us understand how the formula works. So, let's focus on our job. We have dim customer. The user puts a filter on dim customer, and we want to take the filter from here and move it there on dim account. So what we need to do is this jump. Take the filter from here and put it there, knowing that when we have a filter on dim account, applying this filter to the data model will automatically filter the fact transaction table. So we do not need to worry about this step. All what we need to do is this step. Okay? Say yes, move your head, thanks. Now, because the formula is somewhat complex, instead of starting with the correct formula, we will start with a wrong formula. So I write amount many-to-many wrong, which is calculate sum of transactions amount, where I filter the dim account where count rows of bridge account customer is greater than 0. The only difference between this formula and this formula is calculate. Calculate is the most intricate and complex function in DAX because it completely changes how values are computed. And it takes some time to get used to calculate. So instead of studying how this works, we will study how that works. And the result of amount many-to-many wrong, of course, is wrong. You can see that amount many-to-many wrong shows wrong numbers for all the customers. Then we will correct it. And in order to understand the formula, we imagine that we have a pivot table where the user selected a customer, Paul. We want to show only the accounts of Paul. Remember, our task is taking the filter from here to there. All the remaining part is done by the engine. We don't need to worry about it. So the user selects Paul, and the engine automatically propagates the filter from Paul to the bridge table. So in the bridge table, we see only 2 rows. And then our formula starts to work. We have calculate. Calculate will compute the sum of transactions amount after applying this filter to the data model. Filter is an iterator, meaning that filter starts from the first row of a table and then iterates row by row over this table. For each row of dim account, it will compute count rows of bridge account customer. Okay? If the count rows is greater than 0, then the row from the account table will survive the filter. If the count rows is not greater than 0, then the row will be removed by the filter, and we will have fewer rows in dim account. So, because it is an iterator, we start iterating with DAX. And we are on the first row iterating inside this filter, and at this point we compute count rows of bridge account customers. And the question for the ones of you who said that you already use DAX is, what is the result of count rows bridge account customer in this specific moment? I don't remember who said 1. Might be. I saw at least 3 hands, so I want 3 answers at least. You were 1, and of course I remember, you're a beautiful girl, so being Italian, I remember you. And there's somebody else that said, he knows that. 2? Might be?
There are 3 marks in each table, so it will return 3.
So you say 3? Might be?
Guess. Okay.
So we are 1, 2, 3. Who says 4? No idea? 1? Okay. Not always, but sometimes it happens that people say 1, 3, 4, error. Today nobody said error. And one of you got the point. Unfortunately, only 1. Why did you say 1? You said 1.
Filter propagates from account.
This filter propagates there.
Yes. And it doesn't see filter from customer.
You need to remember that filter is automatically the filter context is automatically propagated from the one side to the many side. The row context does not propagate over relationships. So right now we have a row context on team account, which is there, it's iterating. But because it is a row context, it's a cursor, it's an iteration happening, there is no automatic propagation of the filter there. So the count rows of bridge account customer will count the number of rows which are visible in the current filter context now, and there are 2 rows which are visible. Nobody is changing the filter context. That propagation does not happen because it's a row context, it's not a filter context, and so the result will be 2. The result being 2, Mark will survive the filter. Then we go to the next one. We try with Paul, Robert, Luke, Mark Robert, and Mark Paul. All the accounts always yield the same result because nobody is changing the filter context. The filter context is always the same. 2 rows are visible, and so we see all the rows. What we did with the wrong formula was taking a filter from the customer and always select all the accounts without any kind of filtering. But I mean, we knew this is a wrong formula, so it was expected to be wrong. But it was useful to start understanding what happens inside the formula. And the problem of this formula is that we are not propagating the filter from here to there. Now, we have a better formula. And let's try to use it. We start the same. We start with Paul, then the filter is automatically propagated there. We have the correct formula, it's green, so we know it's correct, that has a new calculate here. And we do the same as before. There is a filter is an iterator, so we start iterating over the account table. We start with Mark, and at this point we calculate count rows of bridge account customers. And you might know what I'm going to ask you right now, which is what is the result now of calculate count rows bridge account customers? 0? 0? I've heard 1. It's a common technique, that of speaking with a soft voice, so you think that I don't hear, and you might say anything, which is fine. But I'm not here to test you. I'm just here to make you understand something. So if you give me the wrong answer, that's not a problem. So everybody agrees with 0?
No.
Okay.
So someone said no, and you heard yes.
Someone say null?
Yeah.
Well, null and 0 in DAX are the same number. There's no difference between null and 0. They are just the same thing, mean nothing. And the next question is, why is it 0?
Because of calculate.
Of course, but why? What does calculate does?
We have 2 filters on the bridge table.
But is it different from before? We have a row context on the account. The row context does not propagate. We have a filter context on the customer. The filter context propagates. Looks very similar to before.
But calculate makes row context filter context.
That's exactly the point. Calculate, among the many tasks that does a very important task, which is it takes any existing row context and transforms it into a filter context, then destroys the row context. Calculate doesn't like row contexts. So when calculate starts to work, looks for row contexts around. If it finds one row context, destroys it and replaces it with an equivalent filter context. So calculate will take the row context on mark and say, hey, this is a row context, I remove it and I create a filter context instead. That filter context is applied to the model and propagates to the bridge table. So now the bridge table is filling two different filters. One is coming from the customer and it is filtering the table. The other one is coming from the account and it's filtering the table too. In reality, if you really want to understand how it works, it's not exactly this way. Customers is filtering the customer column and account is filtering the account column. So there are two filters on two different columns working on the same table. And now the number of rows which are visible in the bridge table is the intersection of both filters. And that intersection is empty. So mark is thrown away because the number of rows visible in the bridge table is equal to 0. Then we do the same for poll. And the same happens. We have poll. Poll propagates its filter to the bridge table. And now we have a match because there is one row which is filtered both by the red context and the green context. So when we count the number of visible rows here, the result will be 1. 1 is greater than 0. And so poll survives the filter. And we say, okay, poll will be returned. Then we try with Robert. No way. Then we try with Luke. Again, no way. The account mark Roberts tries harder and says, I want to filter 2 rows from the bridge table because the relationship filters 2 rows there, but it has no hope, it will go away because no rows are visible. Finally, Mark and Paul will try to filter 2 rows, but again we want to look only at the intersection, and there is a row in the intersection between the 2 filters. So at the end, this Mark Paul survives the filter. You see what we did? We start with Paul, and it ended up that now we have a filter on the account table that contains only the accounts which are owned by Paul. These are Paul and Mark Paul. Of course, the same works for any customers. Paul is just an example. So the beauty of this formula is that it's able to take a filter from one table and create a filter on another table by following many-to-many relationship. As soon as we take the result of this filter, which contains 2 rows, and put it on the filter context, that filter context will filter the fact table that is probably somewhere here and has a relationship with the account table. So we will see only the transactions of current accounts owned by Paul. And this explains why the amount many-to-many wrong returns always the grand total for all the rows, and the amount many-to-many correct returns the correct value. Because this does not do any kind of filtering at the customer level, while this does the correct filtering at the customer level. Okay? Makes sense? Now, the point is that this formula, although it works, it's incredibly slow. And it is slow because it needs to iterate over the account table, and for each account propagate the relationship to the bridge table and count the number of rows. Its complexity depends strongly from the number of rows in the account, but more heavily from the number of rows in the bridge table. The larger the bridge table, the more expensive will be to filter it and get the correct number of rows, and the more complex the slower it will become the formula. So even if it is very useful to understand what happens when you want to apply many-to-many, this formula should not be used because it's slow. We will see 2 other versions of the formula which are more compact but slightly harder to understand and way faster than this one. So this is useful for learning. We will see examples where it is still useful to use these formulas, but for a standard many-to-many, this is not the way to go. There are better ways of expressing the same result. The second version of the many-to-many pattern that we will see is way more elegant. It does a calculate of sum fact transactions amount using summarize of the bridge table by dim account. Summarize is the equivalent of a group by in SQL. So this summarize bridge account customer says, return me the rows in the bridge account customers doing a group by dim account ID account. Summarize is a function that is normally used in queries. It's not a function that is commonly used for formulas. But sometimes it is useful. It is most useful in many-to-many patterns. Remember, our task is that of moving the filter from one table to another table. So before we did it with an iteration using filter, now we are doing the same task with summarize. Let's see how it works. We start as before. So we have a filter on Paul. The filter is automatically propagated on the bridge table. And then we have our formula. This time the scenario is different because before we had a filter here. So it meant we had iteration and we were able to follow iteration on the account table. Now we have summarize. And remember, summarize says, return me the rows of the bridge table doing a group by dim account ID account, so the column in the account table. So what does summarize do? It scans the bridge table, looking at only the visible rows, because there is a filter being applied. So it sees only 2 rows in the bridge table, and it will scan 2 rows. And then, because we are asking it to group by a column which is in the account table, and remember that there is a relationship here. So each row here points to a specific account. Summarize will follow relationship with the account table, grab the values of the visible values in the account table following this relationship, and return me a table of account, only the visible account, which are Paul and Mark Paul. All this happens in a single VertiPack operation. So there is no longer iteration. There is just the scan of the bridge table, the following of relationship, and the final result is returned. This is slightly harder to understand, or at least I always find it slightly harder to understand, but it has the great advantage that is very, very fast. There is no iteration, there is just a single scan of the bridge table, and then it returns the value. It is more evident from here that the complexity of this formula only depends on the bridge table. It does not really depend on the size of the account table, but only on the bridge table. And this is the standard behavior of many-to-many relationships. They will be very fast if you have a small bridge table. They will start to slow down as long as your bridge table grows. Until you have a few millions of rows in the bridge table, you don't have to worry too much about performance. Let's say 3, 4, 5 million rows, that's not a big problem. When you have tens or hundreds of millions in the bridge table, then the formula starts to be slow, and you need to be aware of that. Many-to-many work very well, provided that you have a small bridge table. If it is too large, then performance will start to suffer. So the good point of many-to-many used with summarize is that the formula is much faster. There is no iteration at all. It's easier to write. You don't have to write all those lines and greater than 0. It's just a summarize, and it's a very easy pattern. Slightly harder to understand. With all that said, count rows is still very useful, because as we will see in, I don't know which demo, but in a demo we will do later, count rows is able not only to find existing relationships, but even to find missing relationships. Sometimes finding a missing relationship is more important than finding the existing one. I might be interested in understanding which were the product that I did not sell, and this might be more interesting than finding the product that I sold. And count rows is able to find this information. There is a third version of the formula, which is beautiful in its simplicity, and it's nearly impossible to understand. It's not that it's nearly impossible to understand it. I only explain how it works in the advanced DAX workshops, where I spend a couple of hours explaining all the internal details of filter context. But from the performance point of view, this formula is absolutely identical to the summarized one. So they cache each other. If you run one and then you run the second one immediately later, they cache each other, meaning that the query plan of this formula is the very same query plan of the summarized version. The good point is that this is way shorter, so it's very easy to write it. And if you need a pattern, this works just fine. If you want to understand it, don't use this. Use the other formulas, understand how they work, and only then go to the advanced version. I normally teach this to Excel users. Excel users do not want to learn. They want just a pattern. So you say, okay, you have many-to-many, use that, and say, I'm a happy man, I don't need anything else. Does it make sense? Okay. And you have already seen in the demo that it works. Then many-to-many appears in many different scenarios. Another scenario which happens very often is cascading many-to-many. If you really want to hurt yourself, then it means you have the fact table, account, the bridge with the customer. So a customer can have many accounts, but then a customer can have many categories. So a customer can have many categories, a category can have many customers, a customer can have many accounts, and so on. Now we have two bridge tables. One is here and one is there. And if you want to understand how much money is there by category, then you need to do twice the job of traversing the many-to-many. The first step will be, what we have is a filter on dim category, and we want to create a filter on dim account. It's no longer a single step. Now we need to do a first step from dim category to customer. When we know which are the customers of that category, then we will do the second jump from customer to account. At that point, we will have the account, and we will be able to compute our numbers. The pattern is the very same, and of course, account will filter transaction. That's for taking. The pattern is the same. There is no variation. There is nothing new to learn. You only need to jump 2 steps to complete all the tasks. And if you understood the first point, this is very, very easy. How do you do that? This is the pattern using summarize. I did not even write the pattern with filter, because right now we know that filter is low. We have calculate sum of fact transactions amount, and then the filter now is slightly more complex. We have calculate table, summarize, and then summarize. Calculate table is like calculate, but it computes a table instead of computing a number. So calculate table will compute the filter. The filter is this summarize, and this summarize does this jump. We summarize the bridge customer category, this table, by dim customer ID customer, this table. So this box takes the filter from here and create a filter there, and it's the first operation executed by DAX. Then once this summarize is in place, we will have filtered only the customers of that specific category. And then we do the second summarize that takes care of doing this second jump. We have a filter on customer. We summarize the bridge account customer using dim account ID account. This will return a table of dim account, this area, and that table will filter the fact table. So at the end, you will have the final result, which are only the transactions of that specific category. This is the long way of writing, but you can still follow it. If you are a brave and you want to write the short version, you can simply write this formula. Calculate table bridge account customer, bridge customer category. It's very compact, it's very short, nearly impossible to understand. Meaning it's not nearly impossible, you need really to think at all the steps and how they work. So I normally don't use this expression when I have cascading many-to-many because it's too hard to look at the code later and follow what is happening. Moreover, remember that in DAX you cannot put comments inside the formula, so you always need to read it again and again and get a sense out of how it works. Okay? So it's an easy pattern. The cascading is an easy pattern. And we do the jump. Everything is done with just this calculate table. The formula is compact, fast, not easy to read. Cascading many-to-many is a generic formula. You can have as many steps as you want. So you can have 3, 4, 5, 10 different steps of many-to-many relationship, and the formula will still work. You only need to be careful of starting with the table which is farthest from the fact table, and then one jump after the other, traverse the many-to-many relationship until you reach the fact table. One summary for each step, but beware of complexity. Complexity of cascading is depending from the sides, the multiplication of the sides of each bridge table. So if you have 1 million rows in a bridge table, 1 million rows in the other bridge table, the resulting complexity is 1 million multiplied by 1 million, which is 1 billion, 1 trillion, I don't remember, I don't know. Maybe it's 1 trillion rows, which is a large number. So it's very, very easy to hurt yourself if you start using cascading many-to-many without worrying about performance. Many-to-many are fine with a single step. They start to be complex with 2 steps, and they are totally crazy with 3, 4, or 5 steps. If you have a customer that says, I have 5 steps of many-to-many, it's better to leave him than to try to optimize its code, because you will never be able to do anything good. If you have cascading many-to-many, there is an alternative approach, which is not that of traversing all the steps, but of flattening the cascading many-to-many. Instead of, in this data model, we still have customers, categories, and accounts. But this time, instead of having 2 bridge tables, I created a single bridge table. And the single bridge table links account with customers with category. So it contains 3 different rows, and it relates to category, to customers, and to account. The formula that you will need to write is a simple many-to-many, because if you filter the category, you will be filtering the bridge, and because you are filtering the bridge, you will filter the account. If you filter the category and the customer, then both will filter the bridge, and then the filter will be moved to the account and filter the fact table. So as a pattern, it works. You just need some ETL in order to create this table. Normally, a standard view is more than enough. You do a left outer join of the 2 bridge table, and you create the flattened bridge table. And what happens is that this filters the table, this filters the table, and then the account will receive the filter if you use summarize, or apply the filter if you don't use the summarized version. This pattern is worth a trial even in multidimensional. So if you're using multidimensional and you are having issues with performance of cascading many-to-many in the pattern, or if you simply don't understand cascading many-to-many, I personally, whenever I work with multidimensional and I need to work with cascading many-to-many, I need to open my own book and read the instruction on how to create the table, the correct set of relationships, because I never remember it. It's very complex, and you need to design it very carefully. While with the flattened cascading, the formula is simple. There is just a need of some ETL, but performance might be faster. Might be, really depends on the size, on the distribution, and all the stuff we have seen yesterday about column size and so on. Okay? Learning many-to-many is useful because the many-to-many pattern appears in a lot of different scenarios, even in scenarios where you do not expect many-to-many to be present. Let me see how much time I have. Yes, some time. The first pattern that I want to show you is new and returning customers. I guess you know what does it mean to compute new and returning customers. We are AdventureWorks, we sell goods to people, and we have customers coming in our shop and buying something, or coming on the website and buying something. It is useful to know how many customers are coming, how many distinct customers are buying from us. This is the first piece of information. But marketing people are always interested in understanding how many new customers are we reaching. So is my business growing or not? And computing new customers, as soon as you compute new customers, then people will start to ask you, okay, then I want to know how many returning customers are there. I want to know who they are. And then maybe I want to have other information, like how much sales were that of new customers and how much sales were that of returning customers. So there are a lot of different calculations that you can perform. And it's just a matter of writing the formula. Let's do it together. New customers. I guess this workbook already has the solution. But we simply remove everything and we start from scratch. So we write it together. Let's delete. Let's delete number of new customers and we write it together. I have already a measure, number of customers, which is the count rows of customers, and let's delete number of returning customers. If I want to know the number of customers, I can simply create a new measure. Let's call it number of customer, which is the distinct count of sales customer key. This is a very simple calculation. It's a number. We want to use thousand separator, no decimal point. You click OK, the formula is added, and this is the number of customers who came into our shop. That's very easy to compute. Now, if you were to compute the number of new customers, how can you define a new customer? Who is a new customer? An algorithm. Give me an algorithm to check whether a customer is new or not, or to compute the number of new customers. Don't focus on DAX, just on the idea, the algorithm.
The customer that bought now, but haven't bought any transaction.
It has only one transaction, is enough for me.
It has only one transaction?
At least. No.
No? Your idea was fine. A new customer is a customer, first of all. So he's buying something now. Otherwise, he's not a customer.
This is his first transaction, so it should have only.
It's the first transaction, meaning that there are no past transactions.
Yeah.
So if I check if there are transactions now, that's a good step. And then I will add a new condition that says, well, I want it to have transaction now and no transactions in the past. Then it's a new customer. Okay? And you will see that the pattern is very similar to the pattern of many-to-many. Let's create new customers. We compute it step by step. First of all, we check if it's a customer. And we use the pattern of the many-to-many. Calculate count rows of customers, because we want the number of new customers, and we filter the customers where calculate count rows of sales greater than 0. I guess you might recognize the many-to-many pattern. We iterate over the customers, and for each customer we check if the number of rows in the sales table is greater than 0. Thanks. So for each customer we check if there are sales. The sales table is feeling a filter coming from the customer and the filter coming from the date or whatever other table is filtering. So it will show if there are sales in the current period. This number is not yet returning the number of new customers, but it should return the number of customers. The same value as the distinct count, only using a different formula. Let's format it in the correct way. All number, 1000 separator, click on OK. And it looks correct. Numbers look similar. And you know, this is the standard way BI professional check values. It looks correct, so the formula should be fine. And we can go in production without worrying too much about anything else. If it's wrong, the customer and the user will detect it and he will call me. Now we have new customers. It's a working formula, but what we want you to compute is new customer, not only customers. So we need to modify the formula and just slightly change it. I need some more space, and this time we do zoom using the mouse. We don't want only to check that customer sales is greater than 0. We do something more complex. We say, okay, calculate count rows of sales need to be greater than 0. So it has a sale now. The next condition will be it has no sales before. So we again use calculate count rows of sales, because we always need to check the number of sales, but we apply a new filter, that is filter all date or calendar. How do I call it? All calendar, where calendar full date, I hate you, where calendar full date is less than the mean of calendar full date. These start to be a bit more complex. Can you read it from the bottom, or should I increase it a bit? It's okay. Calculate count row sales greater than 0 checks that there are sales now. In end, with another calculate count rows of sales, but this time we override the filter on the calendar, creating a new filter that filters all the rows in the calendar table. So it extends the filter, seeing not only the current month, but all the dates, and then applying a further filter that says, out of all the dates, I want only the dates which happen to be before the first visible row. So if I'm looking at March, these will be all the rows before the 1st of March, all the dates before the 1st of March. And this time, calculate count rows of sales computes a value, that is the number of rows in the sales table, and I don't want this number to be greater than 0, I want this number to be equal to 0. You remember that I said the version with count rows is able to find even missing relationships. So this is checking that that customer has sales today and no sales in the past. Make sense? Somewhat is enough. Then you probably need to study and to spend your time on the formula to make it work. But this formula now checks, if there are sales in the current row and no sales in the past. You click on OK, close, and you see that at the beginning all the customers are new, so new customers and new customers are the same, but then at a certain point the two numbers start to be different. So now we have out of 500 customers, 200 are new, and so on. We have new customers and returning customers. And computing it is very, very simple. It's not very fast. It might be slow because we're using the filter version, but you can do that. And if you think about solving the same problem with multidimensional, Do you have an idea how to solve it in multidimensional? It's a real pain. If I had to solve it, I would search on the web for some pattern. Maybe I wrote it, but I would need to search it. Because in multidimensional, there is no way to detect missing relationship. You can only use existing relationships. So with multidimensional, you should probably create something like a snapshot table that tells you for each day whether a customer is new or not, so that you can aggregate that table and then go further. But this requires a lot of ETL code to be written. And the beauty of this formula is that it can easily compute new customers, but if you take the code, as I don't want to write it again, you take all the code, you can write a new formula, which is sales of new customers. What I want to compute is no longer the number of customers, but I want to compute how much they bought. So they are new, but are they really buying something? Am I getting money out of new customers, or I'm just having new customers? And all you need to do is change this part, count rows, and instead of computing the customers, you compute sum of sales amount. That is, I apply the same filter, I filter the customers which are new, and once the filter is in place, instead of counting them, I compute the sum of sales amount. Sum of sales amount, or whatever you want. There are no limitations. You can compute any value. This time is a number. We use 1000 separator. Click on OK. Oh, there is already sales new customers. And now we have total sales, number of customers, new customers, and sales of new customers. You can easily see that in the case of AdventureWorks, let's see if it fits the screen at this level, okay. In January, for example, I had 1.3 million of sales. This is the number of customers, 1,000 of them. So a vast majority of the customers were new, and they didn't buy nearly anything. The money I'm getting, they only bought $347,000, and the remaining million is of the 600 customers which are returning customers. This kind of analysis is very useful. A lot of people need and want to do. For example, in Italy, we have telephone companies that fight for customers. They will offer you anything if you change the provider from Vodafone to 3 or to other different providers. And it's important to understand that when you steal customer from somebody else, if you're stealing the good customers or the bad ones. And it normally happens that they are stealing the bad ones. So they are only getting customers who are not spending money on phone calls or whatever. And so that kind of marketing campaign is a suicide. They are just getting new customers, providing services, and not getting money out of it. And again, this is something that can be easily done if you learn the many-to-many pattern, because it's always the same pattern, just used in different scenarios. And here you might see that we use the fact table as a bridge between the customer and itself. Whenever you have a dimensional model, you have the fact table that is really a bridge table between any two dimensions. All the dimensions have a many-to-many relationship through the bridge table. Customers and products, you have a many-to-many relationship between customer and products, which is based on the bridge table. Here we are using the many-to-many as a bridge between the customer and itself. Now, let me see. I knew that I had too many slides, and I'm not even trying to show you. Oh, but it seems I need to do that. Anyway, I have the next session, so I can steal time from myself and for your break. Another example I will show you very quickly, so I will not write the code this time. I just want to show you what you can do with many-to-many once you learn them. As I said, whenever you have a fact table, you have the fact table is a bridge between any two dimensions. And imagine that you want to run your user, your customer, want to ask, hey, but out of all the customers who bought a mountain bike, how many of them have never bought, thanks, a mountain tire tube? Because I sell mountain bikes, and if I don't sell mountain tire tube, because they bought a mountain bike, it's likely that they are buying it somewhere else. And I want to know that. I want to know who they are. I want to send them special offers. Doesn't seem like a pattern of many-to-many. Oh, let me skip the SQL part. SQL is boring. You have dim product. And remember, the question is, out of all the customers who bought a mountain bike, how many have never bought a mountain tire tube? I need to select two products, mountain bike and mountain tire tube. I can filter, for example, mountain tire tube here, but where do I filter mountain bike? I need two tables, two products tables, in order to put two different filters on the same data model. And so the solution, if you need to do an analysis like this, is to add twice the product table to the model. In this model, I have sales, customers, order date, and then I have one instance of the product table and another copy of the product table. I will filter mountain bike here and mountain tire tube there. And I need them just to be able to create a pivot table where I can filter two different products. Make sense? Because I have two tables, I cannot leave these relationships active. Because if the user filters something here and something different there, if these relationships are active, then there will always be no intersection in the fact table. And I need to leave the relationships inactive so that the user will filter here, filter there, and nothing happens. Relationships are not propagated because they are inactive. Then it will be my task of propagating the relationship in the correct point in time. The final result that I want to obtain is something like this. Here, on one of the two tables, I filter mountain tire tube. Here I filter mountain bike, and then I see by year, by mountain bike model, how many have bought a mountain bike and the mountain tire tube. How many have bought the mountain bike but have not bought a tire tube, and then the totals for them. I want to have such a report, and then the user can double-click, drill down, and look at the single customer and take decisions. The formula makes use of inactive relationships. So we have two inactive relationships here, and we will activate relationships when we will need them. So this is the complete formula. It's not easy to read, but if you learn many-to-many, you will see that this is a many-to-many pattern, and this is a many-to-many pattern. They are exactly the same pattern, where I only added use relationships. Use relationship is the keyword used to say, in this context, for this subpart of the formula, I want to activate that specific relationship. So we will have this use relationship that activates the relationship with product both in this calculate, and these use relationships activate the relationship with product to check for this part of the calculation. And if you read it thinking at the many-to-many, this is filtering the number of the customers, looking at customers that bought products bought. Count rows of sales greater than 0 means they bought something. And count rows of sales, they bought something of the second product. So this is computing the customers who bought both products, both the mountain bike and the mountain tire tube. This is for having products, so the customer who bought both. If you want to write not having product, the only difference is that you check that one is greater than 0 and the other one is equal to 0. So he has bought the products bought, and he has not bought the product to check. It's very simple as a pattern if you learned many-to-many. If you did not learn many-to-many and you did not understand very well how it works, writing this code is nearly impossible. But I mean, you are here to learn many-to-many, so from tomorrow you have no excuse not to be able to write code like this. And the many-to-many patterns are visible. One is here, calculate, count rows, sales, use relationship is just to activate the relationship, and the second many-to-many pattern is there. So many-to-many are not useful only for many-to-many, they are useful for a wider range of, a wider spectrum of scenarios, and they are very, very powerful. Because, please note, we had to write not a single line of ETL code to compute these values. If you were to do the same in multidimensional, you needed to write ETL code, to write the model, to write complex expressions, and understand how to make them work. One of the most beautiful things about tabular is that you can do most of the analysis without ever reverting to ETL. ETL is expensive. It takes a lot of time to write ETL code, to validate, and to make it work. So what we use here are role dimensions, role keys, active and inactive relationship, and the use relationship function. Last slide. Conclusions about many-to-many. You need to learn with the count rows version. It's easier and gives you a good insight in the engine. Once you learn them, you will use the summarize, which is faster, more compact. But if needed, if summarize is not enough, remember, summarize only finds existing relationships. But if you are searching for missing relationship, then you will need to use again the count rows version, which is fine. Slower, but it's fine. And you have a lot of patterns that can be solved using the many-to-many. If you are interested in that, there is a paper we wrote, a large paper about many-to-many, the many-to-many revolution 2.0, that shows different patterns with many-to-many. The formulas there might be not so optimized because it is an old paper, and then we learn different ways. When it comes to performance, tabular is way faster than multidimensional. So having many-to-many is one of the reasons why you might be interested in converting a cube from multidimensional to tabular. Because in tabular they are really, really faster than in multidimensional. And you can write more complex expressions. Let me see. Only 3 minutes late. Wow, that's incredible. I have to run a bit before. If you have any question, of course, I'm here. So just come.